Good morning, ladies and gentlemen. This is Mrs. Avila presenting your Earth Science lesson for Tuesday, April 21st. So today's essential question is what could be causing ice to melt and temperatures to increase on Earth? We are going to learn this, exploring our topic today, which is exploring energy in Earth system. And today's agenda is we're going to watch the Screencastify video that you're watching right now. We're going to go through the lesson together. You're going to fill out the question in the Exploring Energy in the Earth System document. You're going to copy key concept number 2 in the key concepts assignment. So this is giving you a list of what you need to do. So you will need to have the Screencastify video open. You will need the Exploring Energy in Earth System, parentheses 1.3, lesson 1.3, document open, and the Key Concepts assignment open. So to show you where to find those, on Tuesday, April 21st, you should have 3 tabs here once I load this video. But you're going to click on Exploring Energy in the Earth System, and you're going to open the document. And you already have the Screencastify video open, or you wouldn't be listening to me right now. So you're going to close that. No, go back. So you have that open already. Where do you find the key concepts? Under the key concepts and vocabulary tab, which should be right underneath today's lesson. You're going to click on that and open that click on that and open that document open. And remember that I showed you what you're doing for your key concepts on yesterday's lesson. You didn't have to do anything for the key concepts yesterday. I was just showing you what you were going to be doing. Today, you're actually applying that, okay? So remember that anything that you have to turn in, today you're going to be turning in the Exploring Energy in the Earth System. You have to press the turn in button for that in order to submit that. So for the Exploring Energy in the Earth System, make sure that you press turn in. Now for the key concepts assignment, please do not turn in that assignment because you will be working on it for several days. So let me repeat that so everybody knows what they're doing. You will turn in the Exploring Energy in the Earth System document. You will not turn in the key concepts document because you're working on it for several days, okay? So meme of the day, global warming isn't real because I was cold today. Also great news, world hunger is over because I just ate, all right? So there's some people that debate if climate change is real. Scientists agree that it is. All right, so I'm going to go into Amplify. You do not need to, okay? I'm trying to limit how many tabs you have to have open because that can be confusing for you guys. So I'm going to go into Amplify. You do not, but you're going to go into Amplify. Oh, no, you're not going into Amplify. Sorry, it's 3 o'clock in the morning. That's the only time I can do my lessons, guys. I'm showing you the warm-up. We're just going to discuss that. So this warm-up is showing that snow fell during the night at this location, and it's now starting to melt. And the question is, why do you think the snow is melting during the day? What does energy have to do with ice melting? So some questions to think about is, why did the snow melt? How can you tell energy was involved? Where did the energy come from that melted the snow? What must have happened to the temperature at this location as the snow was melting? So remember that Earth's surface absorbs energy from sunlight. And we learned that when we were studying ocean currents, energy from the sun is absorbed at the surface, and this warms the surface. We can conclude that the snow melted during the day because energy from the sun was absorbed or taken in by the surface. This energy from the surface is also transferred to the air just above it, and that makes it warm. So in this picture, the temperature probably increased as the snow was melting. All right, I'm going to go into tab 2. And on tab 2, we have 2 definitions. We have the definition of energy, the ability to make things move or change, and temperature, a measure of how hot or cold something is. Remember, you can find these words in the glossary if you ever need them. Yesterday, you had a chance to play around or explore the simulation. In fact, it was part of your lesson. You should have gone in there and played around in the simulation. Well, today we're going to be using the simulation with a purpose. So in lesson 1.2, we found evidence of a trend that has been happening since about 1880. And that trend is that temperatures are increasing and ice is decreasing on Earth. So today we're going to investigate what could be causing this. We are going to pay particular attention to energy since we know temperature and melting ice are related to energy. In lesson 1.2, you also read 4 chapters or mini articles that were titled The Effects of Climate Change. You should have learned about 3 topics as you read through that article. And those 3 topics were habitat loss, sea level rise, and extreme weather. Habitat loss is referring to climate changes that are causing some species to lose their habitats, which can even result in extinction of those species. Sea level rise, as ice melts and warmer water expands, rising sea levels cause problems for islands and coastal cities. Extreme weather, warmer water, and air result in more extreme storms and other changes to global climate patterns. These readings and investigations will help explain the cause of our important question today. Remember that energy is the ability to make things move or change. The change we are investigating is a decrease in ice and an increase in temperature. For these things to change, energy must be involved. We are going to use a simulation for today's energy investigation. And as I said, this is the same one that you should have explored yesterday. Models like this are especially important to scientists for observing effects and understanding how things work, so we are able to explore what real changes might look like without harming our Earth system. We've talked about that before. Models are helpful, although we're going to discuss some limitations of them. So remember that our Earth system is composed of 4 spheres. They end in the word sphere, although they're not sphere-shaped. Our Earth is sphere-shaped, but those 4 spheres are called the hydrosphere, which is all the water on Earth, the atmosphere, which are the gases on Earth, the geosphere, which has to do with rocks and dirt, basically the surface of Earth, and biosphere, which has to do with all the living things on Earth. So this image shows the interacting spheres that create the Earth system. In the sim shows land and water on Earth's surface. That's the geosphere and hydrosphere. And the sim shows Earth's atmosphere, including the gases that are part of the atmosphere. In the sim, this is a screenshot of the simulation. Outer space is separated from the atmosphere by a dotted line. So this is the Earth's atmosphere, this is outer space. Energy traveling into and out of Earth's atmosphere is represented by these yellow arrows. Energy absorption is shown by the yellow circles, and it's showing where the surface absorbs or takes in energy, and it can happen in the atmosphere like this one right here, this one right here. Some kind of even look in the background as they kind of disappear. And the amount of energy absorbed by the surface is represented by a yellow glow that will be emanating from Earth. As the amount of energy absorbed by Earth's surface increases, the glow increases in brightness. The amount of ice on the surface, the white area, this one over here, will represent ice, and that can increase, decrease, or stay the same. You've learned previously that energy travels from the sun to Earth and is absorbed or taken in when it reaches Earth's surface. This energy is transferred to the air just above the surface, affecting the temperature. This sim shows a large-scale view of the atmosphere, so it does not show details about how the surface warms the air just above it. But looking at the temperature, that will give us evidence of when energy is transferred to the air. Now, models like the sim can't show or include everything, and they often show some things inaccurately in order to make them easier. Some limitations or inaccuracies in this simulation are that the sim doesn't show the entire Earth all at once, only one angle, but it does represent what happens across the planet. Gases and energy aren't actually visible, but they are visible in the sim. The atmosphere is not to scale. And what were some other ones? It doesn't show clouds, it doesn't show ocean currents, etc. So when we go into the sim, we have a goal. Your mission is to make ice melt in the sim. It says to use Earth's system mode and reset the sim before you begin. So I have to go in and make sure I'm in Earth system mode, and I'm going to reload the Earth system. And if you look, okay, I'm going to look at the ice because this is what we're going to keep an eye on. The ice is down over here. I can change 5 things. I can change the amount of sunlight the surface is getting. I can change carbon dioxide, which is a gas in the atmosphere, methane, sulfur dioxide, nitrogen dioxide, which are all gases in the atmosphere. So I'm going to start with sunlight. Well, how would the sunlight change? I'm not quite sure. Are we getting closer to the sun? Not overnight, but let's see what happens. And I'm going to put it at double time. I'm going to speed it up so I'm not taking too much time. And already I can see the ice is majorly melting. And looks like a good amount has melted. I'm going to stop about 40 for years or time. And if you look in the corner, there's actually a little graph icon that I can pull up. This is showing the temperature is increasing when I increase the sunlight. The surface ice is actually decreasing because I increase the sunlight. And energy that was absorbed at Earth's surface actually increased over time. So sunlight definitely melted ice, right? All right, so I'm going to go into Earth system. I'm going to reload it. Now I'm going to leave sunlight alone, and I'm going to change carbon dioxide. I'm going to change it to, just picking a number, 400. I'm going to press play, look at the ice, see where it starts. I'm going to press play. I'm going to put it at double time. Double time, right? Yep. And already I see the ice melting. It's almost like increasing the amount of sunlight. Wow, that's happening really quick. So I'm going to stop this about 40 for time. All right, I'm going to pull up the graph. So the temperature of Earth did increase. It went from just under 15 degrees Celsius to 18.4 degrees Celsius in the time that I let it run. The surface ice also decreased. It's at about 20% right now. And the absorbed energy, it increased. Kind of fluctuates, but overall from here to here, it's been increasing. So definitely carbon dioxide melts ice. So I'm going to go Earth system, reload. Okay, now I'm going to change methane. And I'm going to put it at 400 just because that's what I did to carbon dioxide. Oh, keep an eye on the ice. Oh, look at that. the ice was over here, and already it's melting. Time is only 6 or 7 there. Oh, I didn't put it double time. Speed it up because I don't want to take too long here. All right, wow, ice is melting. Ice is melting. Ice is melting. Staying pretty constant there. About 40. Pause. Okay, pull up my graph. Okay, temperature increased. Kind of looks very similar to carbon dioxide. The surface ice decreased about 20%. And the absorbed energy, again, there's these fluctuations, but the trend is that overall it's increasing. So the Earth is absorbing more energy. We don't quite know why yet. So I'm going to reset Earth system, reload, yes. Now I'm going to change sulfur dioxide. Okay, take a look at the ice. And I'm going to press play and double time. Whoa, what just happened there? Did you see that? It didn't melt. It's actually it's growing. The ice is getting bigger. I did not expect that the first time I did this. So I'm going to stop this at about 40, just like I did the other ones. About right there. That's way more ice than we started with. Okay, so temperature actually decreased. Surface ice increased. The amount of energy. Hey, do you guys notice something? This yellow line for when we change the sunlight, when we change the carbon dioxide, when we change the methane, that yellow line was up over here. Now it dropped down over here. This is basically saying that when sulfur dioxide increases in the atmosphere, the amount of energy absorbed by the Earth's surface actually decreases. Interesting. We don't know why yet. All right, so I'm going to go into Earth system mode, and I'm going to reload. I have one more to do, nitrogen dioxide. I'm going to set it at 400, just like I did the other ones. Take a look at the ice. I'm going to press play. I'm going to do double. Whoa! What do you know? It did the same thing as with sulfur dioxide. The ice got larger. It grew. It increased. Any of those words work. So I'm going to let it run to about 40, like I've done with the other ones. Pause it there. All right, so the temperature almost looks like it stayed the same. If there's any kind of change, it's very minor. The surface ice, it says it stayed, it increased. Starting here to going up over here, it increased, but not as much as with sulfur dioxide, right? But it did increase. And the absorbed energy, just like with sulfur dioxide, the absorbed energy was definitely less. So we're going to go into the document that you guys had to open, Exploring Energy in the Earth System. This is the document that you opened in Google Classroom. And we're going to continue on here. Remember, we're trying to answer the essential question, what could be causing ice to melt and temperatures to increase on Earth? So here's a screenshot of the before and after of the simulation that we just ran. Right. Remember, the energy absorbed by the surface increased when the ice melted. Absorbed energy is represented by the glow on the surface. So more absorbed energy has a brighter glow, like here, and less absorbed energy means the glow is dimmer, like here. So when would we have seen an increased or brighter glow? When it was getting warmer. So absorb means to take in. We get to our first key concept that you're filling in on your key concepts page. And that's key concept number 2. It's highlighted in orange. That means you're going to be writing this down or typing it, actually. So key concept number 2 is global average temperature increases when energy absorbed by the surface increases. So remember that you had to have gone in and opened up the key concept. You're going to write that in for key concept number 2. And on the next slide, you have to put a picture in. Here's what I'm thinking. You could easily copy this picture in your document and put it in your key concepts document. Okay? Again, you're writing or typing in key concept number 2, and you can easily still this picture to put in the key concept slideshow. I said document, but it's really a slideshow. I should be more careful with my words. All right, so I've been put a note in this document. This one is a document. Time for you to open up the key concept assignment to explain what you did in this part of the lesson to support your new key concept. Oh, 3 o'clock in the morning. You're not writing this down. I'm wrong. You're not writing it down. You're telling what you did to learn this. So to learn this, I'm not going to re-record this at 3 in the morning. I'm sorry, guys. Don't want to re-record this. What did you do? We went into the simulation and we changed the various factors or variables to see what would happen when you increase the sunlight, when you increased the carbon dioxide, when you increased the sulfur dioxide, etc. So you're typing in how you learned this. How did you learn this? And then in the second slide, you have to put down a picture, and that's where you're going to copy this and put it in that one. Okay, so sorry about that, but I'm not going to record at this point. Bye, Eli. My husband's leaving for work. Okay, debriefing the submissions. All scientists, including climate scientists, constantly make and evaluate claims as new evidence comes along. When scientists find new evidence to support their claims, it makes their arguments stronger. However, scientists sometimes need to discard or get rid of their claims. Sometimes scientists make claims that might seem to be strong at first, but when they collect new data, they realize their claims are incorrect or accurate. This is actually very helpful to science because disproving an inaccurate claim helps scientists make even better claims and collect better data. Below is a claim that some people make about climate change, especially when people first hear that temperatures are getting warmer. People might believe the claim because it seems to make a lot of sense when you first examine it. For example, we all know that an engine or a fire is hot, so maybe having more of those things is causing climate change. So the claim that people believe often is more hot things are now on Earth's surface, such as forest fires, heat from machines used in factories and cars, body heat from people and other organisms, or volcanic eruptions, which are increasing Earth's temperature and causing the ice to melt. In the diagram below, the large red square represents how much energy comes to Earth from the sun each day. So this is energy from the sun. And the tiny red dot, this one right here, tink, represents the total of all heat energy produced by other sources on Earth. So all those other things we talked about, engines, forest fires, volcanic eruptions, etc. So scientists realized that this claim couldn't be true. They used many kinds of data, but none of it supported the claim. The amount of energy that Earth's surface gets from sunlight is many, many times greater than any other source of energy. Every one of California's largest forest fires, which is a fire that burned many square kilometers of forest, didn't change the global temperature enough to be measurable. A change to the overall temperature of the whole Earth must therefore be related to energy from the sun. So this is the California Rim Fire of 2013, burned over 1,041 square kilometers, about the size of New York City, but had no measurable effect on global average temperature. So based on evidence, we can reject an increase in heat sources at Earth's surface, such as factories, cars, or fires, as a valid claim for increasing Earth's temperature and causing the ice to melt. So then what are some other claims that might explain why Earth's temperature is increasing and ice is decreasing? So please write one claim below that you might believe is the reason for more ice melting on Earth's surface. So my claim is that more ice on Earth is melting because, and you're going to type your answer here, blah, 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 blah. What do I think? Okay. That's the one question that I mentioned at the beginning that you are answering. Okay. After you answer that question, you're going to make sure that you turn in your assignment, please. Which means that you have to click the little button that says turn in. All right. Now, what should you have learned in this lesson? Sources of energy other than sunlight are too small to affect global average temperature. Every model is accurate in some ways and inaccurate in other ways. Global average temperatures increases when energy absorbed by the surface increases. All right? So one thing I did forget to show you, or not forget, but I didn't open it up beforehand, is that key concept. Is Let's see, where's my key concepts? Is that the right one? Oh, sorry, not the right one. Okay. Not sure that's the right one either. Yes, it is. Okay. So as I showed you in Monday's video, you have to go in and you have to type in how you learned that key concept. So you have to go to slide 4 when you open up your key concepts, and you have to type in what you did to learn that. For instance, we did the simulation and tried changing the sunlight. We changed the carbon dioxide. We changed the amount of methane. We changed the amount of sulfur dioxide. We changed the amount of nitrogen dioxide to see what effect it would have on the ice. And then in the next slide, you had to add graphs, pictures, drawing, etc. there. And as I said, in your document, you can easily go grab that picture to put it in your key concepts, this one right here. Okay. So that's it for today's lesson. And again, don't forget you're turning in your exploring energy in Earth system document, but do not turn in the key concepts document. Okay. Have a good day, guys. Finish your work. Behave. Hope you're doing well. Bye-bye.